Hello, scientists. I'm going to review how to use a Desmos graph to make a prediction. So the first thing I want to do is remind us what we're looking at here. This is a distance versus time graph. We know that because the axes are nicely labeled. This is also a well-placed graph. Notice how we can see both the y-axis, the vertical one, and the x-axis, the horizontal one, as well as that 0, 0 point right here. And we can see all of the points that we've graphed. So we can really tell what this graph is showing us. We can really use this graph to help make a prediction. Now, in this example, you have already graphed your data. You've got your X data in the first column and your Y data in the second column over here. And then notice above X, above the table, it says X is time in seconds and Y is distance in meters. And that relates to what we have written then in our labels. When I click and hold anywhere on the line, notice how the coordinates of that point show up wherever I've clicked. And as I move this point where I'm clicking on the line, those numbers are changing because they're telling me the time and distance information that this line is predicting. So I'm going to go ahead and line this up right at the 82nd point. So see how that first number is 80? The first number is always going to be your X value. Remember, X in this situation is time. And the second number will always be the Y value, which in this example is distance. Now, one way you can remember that is that it's X comma Y, and X comes first in the alphabet. Another way you can remember that is that 80 is your time value because that first column in your data table is your time. So wherever you have graphed in that first column is showing up as the first number when you click on the line, which means the second number when you click on the line, I'm going to try to get back to 80, is going to be your distance value because it correlates to that second column in your data table. So what this is telling us is that when a ninth grader walks for 80 seconds, they should on average walk 63.413 meters. And I'm going to round that distance. I'm going to say 63.4 meters because I don't need all of those decimal places. We're not that exact with this experiment. So if I'm going to make a prediction, let's say I ask you, how far will the average ninth grader walk in 25 seconds? Well, notice that there's no data point at 25 seconds, so I'm going to have to click on the line. And then I want to make sure that I click right at 25 seconds. So I'm going to move the mouse while holding it down until that first number, that time value, is exactly 25. And sometimes you have to go back and forth a little bit. Sometimes you miss it, but make sure you get it right at 25. All right, so there we go. Oh no. So when the average ninth grader walks for 25 seconds, they will move 19.7 meters. That first number is our time value, the predicted value I've asked you to look for. And that second value is how far is the distance part of that predicted point. So that is how you make a prediction using a line on Desmos. Now, this will tell you the coordinates of any point on this line. So if you're calculating your rate of change and you need 2 points on your line, you can also click in any two places and record the coordinates, the X and Y value for those two different points, and use those values to calculate your rate of change. All right, scientists, thank you.